Hello everybody and welcome back to another forecast. So if you've been watching my channel for the past few days, you know that I've mostly been looking at this setup that's been happening in the southeast. And I've been looking at snow a little bit just because it is important, but quite frankly, this is not what this forecast is going to be about. This is mostly about the severe weather risk for the south. Really quickly, I'll look at snow. So essentially, it's not it's going to dump quite a bit of snow on Nebraska and Kansas with this huge trough that's going over the United States right now. If I look to the United States sector, you can see everything, right? So this is at 500 millibars, which is a few thousand feet in the atmosphere. Essentially, this thing is spinning counterclockwise and pulling in a lot of dew points, aka moisture, from the Gulf of Mexico, and just everywhere here is going to see a lot of snow, but mostly on this backside because that's how low pressure systems work. So, what I'm going to look at is the total snow accumulation, just because I do quite like that product. If we look at 6-hour snow accumulation as well, you can kind of see where heavier snowfalls are going to happen. Mainly over in Nebraska and Kansas as this moves across the United States. And as we speak, this is probably about to start dropping some snow in the southeast Colorado. But as it moves past Iowa, it doesn't look to be as severe. Although in 6 hours, 3 inches of snow, upwards of 6 inches as well. That is quite a bit. This is also showing a little bit of heavy snow here, which doesn't really fit with the rest of the model, to be honest with you. But we will see with that. And most of that snow here is probably going to melt pretty quickly. But as I said, the main focus of this forecast is going to be the severe risks, which is essentially what everyone else is also looking at. So if we look at near Texas right now, you can see this is a low pressure system, which I'm going to highlight in pink right now. Right here, low pressure system spinning counterclockwise. And what it's doing is pulling in these warm temperatures from the Gulf of Mexico, which are actually really destabilizing this region as we speak. Right now, this is the current satellite data, and since it's still just about morning, it's kind of hard to see. But currently, there's this line of storms right here in central Texas, and this is going to move this direction like so. And as more and more storms feed up into this system, this is just going to turn into a bigger and bigger line of storms. In my last forecast, I predicted that we would see a development somewhat like so. So we'd start with an early line of storms right here, and a few discrete supercells down here. They're not beautifully drawn, but you get the point. And these would create some tornadic storms, which could really be dangerous. However, something I failed to take account of is the fact that nothing is really going to form these storms, right? So our main method of forcing, which will actually create those storms and make them happen, is going to be on this cold front, which is kind of hard to see here, but it's easier to see here. So this line of blue to red, this is essentially where the cold front is located. And as this moves across, it's just going to push all those dew points out. And as those dew points get pushed higher in the atmosphere, stuff has to be forced there, and that's how we get this huge line segment that's going to form. Essentially, there's nothing that will actually force this to happen. There's no convergence here. Most of these winds are going in basically the same direction, right into this squall line of storms. It's going to move east. But something I did do right is the fact that down here, there's a significant discrete risk if it were to happen for whatever reason it would be. This has been highlighted by the SPC. So earlier yesterday, I believe, yesterday night, this 10% hatch region for tornadoes, only in this region, significant tornadoes. But they finally pushed it west to Texas, which is something I'm very glad they did. Obviously not because storms are happening, but because of the fact that I thought they were kind of sleeping on that risk a little bit, and it seems like they are. In this sector over here, I'm going to move to the rapid refresh model just to get recap. So what 3-cape is how much instability is in the lower levels of the atmosphere, and that's where tornadoes thrive, is in this 0 to 3 kilometer region. You can see here these brighter colors, that's a whole bunch of instability for these tornadoes to work with. And as we move to about 2 p.m. today, 1 p.m., I'm going to take a sounding right here as well. Essentially, this is what the atmosphere looks like. This is our photograph, and we have quite a bit of curvature in these lower levels, which is something that we have been seeing even 3 days ago, although not nearly as severe as the ones I saw the other days. But there's so much 3-cape here, and there's a whole bunch of cape for any systems here to be had. This blue line here shows an air parcel as it rises up into the atmosphere. And right here, this is going to this air particle would rapidly, it's going to be hotter than the environment itself, which means it's going to keep on rising. Essentially, storms are destined to form as long as something forces them to form. If nothing's forcing these air particles to rise, then they're not going to rise and create storms. But they'll be rising freely if they do rise, which is very dangerous. Not to mention a moist layer up to 800 millibars in the atmosphere, which is quite a good moist layer for a situation like this. Now I'm going to look at the HRRR model, and we're going to look at simulated reflectivity. This kind of becomes an idea of what we're going to look at on a radar, right? So if this is where we are right now, the time we're at, we can see this right here, this line of storms, and a little bit of convection right down here, as we're saying. As this moves east, it's basically going to pick up anything it has. And while the main threat is wind, this whole line of storms is going to move across the United States and down here. Even into tomorrow, this is going to be rapidly rotating. There's going to be so many notches in this thing that could create very significant tornadoes. And that is what the SPC has highlighted right here. Essentially, this entire region is at risk for severe tornadoes, just that they can only have a certain area where it's actually hatched, which essentially means they can say it's a 10% greater or greater possibility. There's a possibility this will even be upgraded as we go further into the day as well. Even into tomorrow, there's two 10% hatched regions for tornadoes. And I'll look into that a little bit. But this is what the SPC is saying, and the main threat is definitely wind. So when you get a huge line of storms like this, it often has a front side that switches from negligible wind from like 10 miles an hour to something very extreme, like sometimes even 60 miles an hour for a time. And that can cause extensive wind damage across a huge area. What we call this line of storms is a quasi-linear convective system, which is, I'm going to abbreviate as a QLCS, just because that's a little easier for me to say and it takes less time. Essentially, in a QLCS, you have line of storms, which we're going to see, and I'm going to draw out right here. It's a line of storms, something like this. And this is going to be moving this direction with the cold front. But what will happen is if you get really close, you can kind of see these little notches. They'll go kind of like this. Essentially, that's like having a supercell in there. Right here, you can form a tornado because you have warm inflow going in and cold outflow on the other side. The cold outflow would be all the rain-cooled air. The warm inflow from this huge moist layer that's happening and all this moisture being pulled up from this low pressure system, that creates a very good chance of many, many notches in this huge QLCS, right? So this isn't extremely well defined by all this on the HRRR, but you get the idea. It's a huge line of storms, and this will have so many notches and so much rotation. If we take a sounding, I'm going to use the NAM-NST for any of these points, right? We can see how much curvature there is in these photographs, and that's the main way that I can see what's really going on in these storms. Here you can see how just incredible curvature right here. I mean, 60 knots of flow in the first half kilometer of the atmosphere is absurd. That's in the first kilometer of the atmosphere here. That is a lot of inflow, and that's very dangerous, especially for this system moving across such a huge area. And this is potent across the entirety of this region. If I took a sounding here in a few hours when the storms get close, here before when the storms were less dangerous to me, and I took a sounding there and you could see a similar result. This whole system is extremely dangerous for the Southeast, and even as we move into tomorrow. So this is January 9th on Tuesday. I'll move the sector a little bit as well. So if I can see here, temperature, you can see this is where a low pressure system is most likely centered, and dew points as well kind of show that. This is going to be our warm sector where supercells will form. Again, though, it's very similar to what happened in Texas, as if nothing forces these storms to rise, they won't. And the only thing that'll happen is this huge QLCS that moves across as well. Storms also thrive in the afternoon. So that's most likely why in the SBC's region they have a little separated area in Georgia from the hatch risk. Although I wouldn't be surprised if this just gets connected at some point as we get closer to the event. Essentially, what I'm saying is this is an extremely dangerous system that if you live in the Southeast, you have to be prepared for. I'd also like to see how this forms as the day goes on, just because of how my forecasts have been very centered on the Texan region. I have been thinking this is the main threat, but it does seem more likely that Louisiana is the main threat, just as all of this rises in here. And there's going to be a lot of 3 Cape. Again, if I look at a triple R model, I can see 3 Cape, again, where the storms do the best. The most 3 Cape is definitely in Texas earlier on in the day, but it will continue as we go on into Louisiana, Alabama, and Mississippi. Although it will die down a little bit after the night, because storms do have a harder time at night. But although nocturnal storms are very likely with this whole system, this may also help to see the entire United States under all these lines. Again, as this moves across the United States, there's lots of danger here. And similarly to the Texan scenario today, tomorrow the Carolinas will see some 3 Cape rise into the region, which could lead to a few supercells. But if we look at supercell composite, which essentially shows us how likely supercells are, there is some likeliness of them, but there's just not enough forcing to really make it happen. So I'm gonna update my past forecast here, but instead of having the system that moves like so, where it has a line and then supercells, I think this is possible, but these won't be supercells as much, and I do believe these have a better chance of forming their own little QLCS. This will have tornadic activity. That's not a good tornado, but essentially this could have tornadic activity. And as this moves together into a bigger line, this will all have tornadic activity as it, continues to ravel its way east. Seeing as this is an archive channel, mostly for my own benefit, I am glad to see that this has kind of come to fruition. I still think that the tornado risk near Houston is very dangerous, and I am glad that that has been outlined in the SPC outlook, just because I was a little scared that that would get slept on for quite a bit. As this system moves on, it's going to be kind of interesting to see what happens. We can see here through reflectivity, and very little stuff forming right here, but there is a little convergence band right here that is kind of forming a few storms right in this little region. If these storms actually take advantage of their atmosphere and the conditions they're in, these right here, this cluster right here, could become very dangerous. And especially some storms that could form on the backside of this, maybe a few little dots. But again, that's where they start. That's where supercells start as they move. These will move northeast. As those supercells begin, anything can get formed, and any forcing here will lead to it's a really destabilized environment. Anything that happens here will be extremely dangerous to people living here. Really, just a huge dangerous event today, so people need to look out. But definitely tomorrow, we'll see what happens. And I'll probably have another forecast or overlook on what really happened in the future. So with that, thank you for watching, and stay safe out there with this whole system.